John Allison from Marksville Ames. I'm here to work through problem number 3 on the 2025 AP Precalculus Exam. I'll work these problems cold. I have not looked at the problem beforehand, so you're going to see the entire thought process as I work through the problem. I do this so that I can kind of simulate what my students feel when they're working through these problems. They open the test and they immediately have to begin working, and also so that I can communicate to them and to other teachers that it's okay to make mistakes. You may find a mistake in here, and if you do, that's okay. I'd be glad for you to point it out and put in a comment what you think I did wrong or what you think I could have done better. And so we're all human and we all make mistakes. I want my students and other teachers to know you don't have to be perfect to score well on this exam. And so with all that said, put up the document camera and let's get started. This is going to be my solution to the 2025 AP Precalculus, problem number 3. All these will be on a YouTube playlist. My solution to it, okay? So I'm going to open the document now. I don't show the document on here because College Board considers that a violation of copyright. So I will put in the description a link for you to find the released FRQ so you can follow along if you choose. So this is the no calculator part of the test, question 3. We know it's going to be a periodic function, and just like we thought, it is. So for a guitar to make it sound, the strings need to vibrate or move up and down or back and forth in a motion that can be modeled by periodic function. Time t equals 0 seconds. The point x on one vibrating guitar string starts at its highest position, 2 millimeters above its resting position. Then it passes through its resting position and moves to its lowest position, 2 millimeters below the resting position. Point x then passes through its resting position and returns to 2 millimeters above the resting position. This motion occurs 200 times in 1 second. Sinusoidal function h models how far point x is from its resting position in millimeters as a function of time t in seconds. A positive value of h of t indicates the point is above the resting position. Negative value of h of t indicates the point is below the resting position. The graph of h and its dashed midline for 2 full cycles is shown. 5 points f, j, k, and p are labeled in the graph. No scale is indicated and no axes are presented. Determine possible coordinates t, h of t for the 5 points. So I'm going to do my best attempt to draw this graph. It won't be perfect. And we have F, V, J, K, and P. I would not have drawn the graph on the exam, on my answer sheet. Notice they did not put the places for you to write the points in the graph because it's on the exam, or on the computer. It's 3A. So we're going to, this is 3A. We'll do 3B down here. So the first thing, at time t equals 0, the point x was at its highest position, 2 millimeters above its resting position. So we're going to call the resting position 0 millimeters. We're going to call the highest position 2 millimeters. That's going to make the lowest position negative 2 millimeters. We're going to start the highest at 0, 2. So we're going to say that F is the point 0, 2. Then G is going to have a y-coordinate of 0. And J is going to have a y-coordinate of negative 2. And K is going to have a y-coordinate of 0. And P, we're in the room here, is going to have a y-coordinate of 2 again. So what we need to figure out is the period of one complete cycle. And we know that this motion occurs 200 times in 1 second. So let's read that again. Starts at the highest point, passes through resting position, moves to its lowest position, below the resting point, passes to its resting position and returns to 2 millimeters. One cycle occurs 200 times in 1 second. So that means one complete cycle is 1/200. So this point, P, is 1/200. In 1/200th of a second, one cycle completes, because the cycle completes 200 times in every 1 second. So that means point P's x-coordinate is 1/200. Half of that would be the x-coordinate of point J. So that's going to be 1/400. 1/2 of 1/200 is 1/400. Halfway between 1/400 and 0 is going to be point G, so that's going to be 1/800. And that means it's going to be 1/400 plus 1/800 to get to here, to point K. So this would be 2/800. So this will be 3/800. And we will make those our 5 points. So B, the function can be modeled by h of t equals a sine b of t plus c plus d. Notice they did not start with cosine, even though our first point was its highest point on the curve. We need to find A, B, C, and D with no calculator, right? So we know that A is the amplitude. The amplitude here is 2. So we know A is 2. Fine. We know that 2 pi divided by B is the period, and the period is 1/200. So that means that we're going to solve that by, you can cross multiply, you can multiply by 200 B, but we're going to end up with B equals 400 pi. Ooh, who would have guessed that? If you think about this, this is a horizontal compression from 2 pi to 1/200, which is a very small number. C plus, let's save the C for a second, and we'll figure that out in a minute. And then we're going to do plus D. D is 0. There's no horizontal shift in this case. Let's see. There was never any indication that the guitar string was a certain height above the ground. Okay. So typically, the sine graph would have started here and gone up. Like so. It has been shifted 1 going to be from here to here. It would have been 1/4. It would have been like this. It would have completed its cycle in 1/200. So yes, it would have been here. So this is shift. This is 1/800, 1/800, 1/800. This is going to be a shift to the left by 1/800. We need this point. Yes, it would have shifted. This would be at negative 1/800. This is 1/800. This would be negative 1/800. It's a shift to the left by 1/800. We'll see how that goes. That was part B. So A is 2. B is 400 pi. C is 1/800. And D is 0. Let's look at part C1. On the interval, T1 is T2, where T1 is G, T2 is J, which is always true. Okay. H is negative because the midline is 0. So this is going to be C or D. And H is decreasing from T1 to T2. So negative and decreasing. The answer is D, negative and decreasing. On T1 to T2. On the interval T1, T2, describe the concavity of the graph of H and determine whether the rate of change of H is increasing or decreasing. So C2, H is concave up on T1, T2. Therefore, the rate of change of H is increasing. And that pretty much does it for question number 3. Not too bad. Some fun numbers to work with up here on the A, B, C, and D, but not too bad. We'll get this one uploaded and do problem number 4.